Algebra 1, here we go, getting into chapter 5. Talks about rates of change and slope. Okay? Our essential question is, what is the relationship between rate of change and slope? The relationship is that they're the same. When we talk about something like miles per gallon, feet per second, those are all slope. Okay? We've talked a little bit about slope before. It's a rise over run. It's a rate of change, the vertical change over the horizontal change. Okay? Slope and rate of change are the same thing. When we talk about slope, we use the letter M. Okay, you've probably seen that before too. And the equation to find slope, if you have 2 points, two ordered pairs, and we labeled one x1, y1, and the other one x2, y2, it would be y2 minus y1 over x2 minus x1. Remember, it's the vertical, the up and down, the rise and fall. That's why the y's go on top, and then your horizontal change is your x's. Okay? So, here's an example in the book. It's problem 1 on page 314, and they're talking about finding the rate when they give you a distance and a time. So they've given you 2 points here, whether you take them off a graph, a line, or they give you 2 points. We're going to call our time is our x-coordinate and our distance is our y-coordinate. So this is like T1 and D1, T2 and D2. So 520 minus 260, 2 minus 1. That's 260 over 1, or 260 feet per minute. Okay, that's our rate of change when you're talking about a distance and time problem. All right, problem 1, 314 in the book. Pretty straightforward. Okay, let's take a look at some more here. Finding the slope. Okay, a couple different ways of looking at it here. First, they give you 2 points on a line. You can look at a graph, find the 2 points right where they cross right there on those crosshairs. Take any 2 points off that line. Doesn't matter what 2 points you take off the line. And then x1, y1. We can look at it like this. x1, y1. x2, y2. Okay? Then just plug it into the formula. -1 minus 1. -2 minus 1. Remember now, -1 minus a 1 is -2. It's not 0. And -1 minus 1 is -3. Negative over a negative makes it a positive 2/3. So that's our slope of that line. Okay? A couple special cases here. Slope of a horizontal line. Remember, horizontal is flat. Okay, straight across, horizontal, like you're looking at the horizon. Okay? There is no slope to it all here because the slope is 0. And you can see by taking 2 points, when you take the 2 minus the 2 on top, okay, you get 0, and 0 divided by anything is 0. And that'll always be the case with a horizontal line. The y values will give you 0. Okay? So that's a 0 slope. If you have a vertical line, now when you take your y's, like 2 minus a -1, and then the x is -2 minus a -2, remember this becomes a plus positive. So you get 0 in the denominator. Every vertical line, straight up and down, gives you 0 in the denominator. And you can't divide by 0. Remember, a fraction is the same as division, 3 divided by 0. You can't do that. You can't have 0 in the denominator. Okay? So our slope here is undefined. It's not 0. Okay? It's undefined. There is no slope. Okay? Make sure you get that straight. So looking at the kind of slopes in our lines, and this is kind of a heads up for you when you're doing slopes. If your line is going up to the right, that's a positive slope. Okay? Always got to be positive. So if you have a line like that and you find the slope and it's negative, you know you made an arithmetic error. If it's going down to the right, you're going to get a negative slope every time. And what we just mentioned, if it's flat, horizontal, the slope is 0. If it's vertical, straight up and down, the slope is undefined. Okay? Hopefully that's been helpful. A couple good diagrams like this in the book. Tomorrow we'll start looking at examples of this and some application. Okay? We'll see you then. Bye.